Hola amigos, so now let's continue with range and endurance for propeller and jet aircraft, and from this lecture we will be exploring these graphs using previously derived formulas for propeller and jet engine for range and endurance of respective airplane or engines. Okay, so range is this and endurance is this for a propeller driven aircraft, and similarly we have derived the jet engine aircraft range and endurance. In propeller it's just power over here, and in jet we have thrust over here. And now let's move on to this topic, that is we will be exploring or relating these formulas with these graphs. Okay, all these formulas. Okay, so here we have the power required and velocity variation for a propeller driven aircraft. Actually we know power required variation for a given range of velocity remains the same for a propeller driven or jet engine aircraft for the same design or layout of an aircraft. Okay, but here our distinction for propeller is only because of the range and endurance which are different from the range and endurance of jet engine. Okay, so keeping that in mind, we have this propeller variation for power required and velocity variation, which we know that power required is directly proportional to v cube. That's why it has higher curvature as compared to thrust required and velocity variation, which has a curvature of v square, because thrust required equal to drag and drag is directly proportional to velocity square. And here if we see the velocity, we are comparing, or say we are computing the aircraft velocity for a propeller driven aircraft to make its range maximum or endurance maximum, or to fly at that velocity at which it should cover the maximum range or the maximum endurance, or that is it should cover the maximum distance, or it should fly in the air with maximum time for a given tank of fuel. Okay, similarly we have done this for jet aircraft. We are relating the velocities, or getting to know about the velocities for which a jet engine aircraft will be flying at that velocity at which its range will be maximum, or it will be flying with that much velocity at which endurance will be maximum. So from this graph we have the power required variation like this, which shows that power required minimum is this point, and velocity at this point is the velocity which we get at endurance maximum. That is, we know the for power required formula endurance is this. Okay, so this is the endurance and this is the range for a propeller driven aircraft. Now if we want to fly our aircraft with the aircraft has to fly at a certain velocity so that it should cover this much range, or say it should cover the maximum range and maximum endurance. So when the range will be maximum, CL by CD, this should be maximum, and for endurance to be maximum, CL by CD, which actually is CL raised to power 3 by 2 divided by CD. These aerodynamic ratios should be maximum for range and endurance to be maximum respectively. And while it does not know anything about the aerodynamic derivatives, or say aerodynamic coefficients actually, and we know lift equal to weight, and from this we can calculate the velocity knowing about the CL. Okay, from that we can compute the CL-CD ratio, and upon knowing that we can plot the variation of CL-CD with respect to velocity, and from there we will see that corresponding velocity at which the aircraft will be flying will be with respect to CL by CD max for range maximum. Okay, actually we will be learning about the velocity at which CL by CD is maximum, for which we know the range will be maximum. Similarly we will see CL is about 3 by 2 will be CL is about 3 by 2 by CD will be maximum, and corresponding velocity we will compute, and from there we get to know about the endurance at which velocity it gives CL is about 3 by 2 by CD max. At that velocity we will see endurance will be maximum. So from this graph we have power required minimum over here, and velocity corresponding to this is also the velocity at which the endurance is maximum. And when the tangent is drawn at any point on the curve, the minimum tangent on this curve gives us the velocity at which the range is maximum for a propeller driven aircraft. And from the formula of range and endurance over here we know that endurance is dw by cp. Okay, so for a initial weight w0 and final weight w1, initial w0 and final w1, and we know the aircraft weight changes over a period of time, it decreases actually, which is why it is decreasing, and when this instantaneous weight multiplied by 1 by cp will give us the endurance for a change over a period of time. Actually it will be for initial and final weight of the aircraft when the whole weight of the fuel get consumed. Okay, so the endurance will be then the area under this curve, because we know from this integral dt is a time interval. Okay, upon integrating the time interval and upon integrating this dw by cp we will get the endurance, or the time period, maximum time it will fly in the air. Okay, similarly upon multiplying by v infinity we will get time into velocity as distance, which tells us about the range aircraft will cover and with respect to the earth's surface while flying in the air. Okay, so from here we see that v infinity by cp multiplied by dw will give us this range. So v infinity by cp multiplied by dw, when integrated over a range of w0 to w1 similar to this graph, we get the range for this shaded area. So now moving on to this graph that tells us about the aerodynamic ratios. Like here we look at CL by CD ratio, we covered that for CL by CD ratio, or CL is about 3 by 2 by CD ratio for propeller engine we are talking about, and their variation with velocity we are exploring over here, that CL by CD variation is like this, and CL is about 3 by 2 by CD is this, and this is the maximum point at which CL by CD is max. Okay, CL by CD is this curve, and for this curve CL by CD is max at this point, and for CL is about 3 by 2 by CD it is this, and here it is less than this CL by CD, because as CL increases CD also increases, because we know CD is a function of CL as well, because CD is equal to CD naught plus CDI, where CDI is equal to KCL square. Okay, so as CL increases, we know velocity decreases. Okay, so as velocity is increasing over here, therefore CL is decreasing. Okay, so CL upon when it is CL is decreasing, the numerator will have a value of 0.5 or 0.3, something like that. So based on that, this will be having higher values, that's why it is going above this graph. And when let's say 0.5 is here and 0.5 raised to power 1.5 will be even lower value. Okay, that's why we have this graph which is below this curve, and velocity corresponding to this CL by CD max is the velocity at which the range will be maximum for CL by CD max. Okay, and for this we have CL raised to power 3 by 2 by CD max, that is velocity at which this endurance will be maximum for the propeller driven aircraft, which is actually operated by a reciprocating engine. And now moving on to the jet aircraft, we see that thrust required, that is equal to drag, which is directly proportional to V square. We know this by heart, and this is the quadratic curvature. We will say that here we will see that thrust required is minimum at this point, and velocity corresponding to this is the velocity at which endurance is maximum, just like propeller. Power required minimum at which the velocity is maximum for power required is minimum for an aircraft at that velocity, and when the aircraft fly at power required minimum, it will stay in the air for maximum time, which is why we are having the velocity corresponding to the maximum endurance. Similarly over here, if the aircraft flies at the minimum thrust required here, and that will be the velocity at which the aircraft will be flying to be in the air for the maximum time, and that velocity will correspond to the maximum endurance. Okay, which is ultimately the thrust required minimum point. And for here, endurance maximum velocity is the power required minimum point. And similarly over here, for the tangent drawn over this curve at any point is minimum at this point. Okay, so at this point here we saw that range is maximum for this point, because at this range maximum we see CL raised to power 1 by 2 by CD max, and the velocity corresponding to this CL 1 by 2 by CD max is when the range will be maximum, and it is this velocity. Okay, and similar to this aerodynamic variation with velocity, okay, aerodynamic variation or aerodynamic ratios with velocity for jet engine we have plotted over here. This is for propeller and this is for jet engine we are seeing, and CL by CD as usual we can see it is like same this graph, and here for jet engine we have this CL raised to power 1 by 2 by CD. In propeller engine we have CL raised to power 3 by 2 by CD for endurance, and for jet engine we have CL raised to power 1 by 2 by CD for range. Okay, so based on this we got the values of corresponding velocities just like the propeller engine over here, and similarly we got these values of velocity at when the endurance is maximum for thrust required minimum. Okay, so when the aircraft is flying and when the minimum thrust is produced by the engine, it will cover the maximum time in the air. It will be in the air for the maximum time actually. Okay, and that velocity at which it will be flying will be the velocity at thrust required minimum, or say velocity at endurance maximum. And this graph is similar to this, only difference is here CL is about 1 by 2 by CD is plotted against velocity, and here CL is about 3 by 2 by CD plotted against velocity. Thank you.